Hello, welcome. I'm Joseph, and today I want to talk about embedded Swift. It was showed off in WWDC. Embedded Swift, first of all, is not new. However, what they showed off in WWDC is new. It is a Swift first entry point, meaning that when you go to the source code and you look at the embedded examples, and I'm working on the Pico W right now. So when you go to the Pico W and you go to main.swift, there is a main entry point. The ESP32 is a little bit different, and they do some auto injection of app main. So if you look at the ESP32, and by the way, it's the ESP32 C2 or C3 and C6. They don't support their other architect for the S line for like the S2 and S3 as either. So you're going to be limited to ARM and RISC architectures, and that's part not really of Swift, but the LLM or LVM. And so yeah, if when you go to the main here and you look at this, there is a declaration for C to say app main, and then they do some magic to auto inject it into this dummy C file, and then that, I don't know, it's just the way that the expressive framework works. Anyways, I wanted to show that. While this is really, really awesome, another thing is that all their examples only compile currently on Mac OS. This is because they don't want to. I'm a little baffled on this because in the WWDC they also brought up that we're going to give a better developer experience on other platforms other than Mac, and this is one thing that already it is not that. So yeah, you need Mac OS. You need to download their nightly or their 6.0 branch. I do have this running on our compiling on Linux currently. In fact, I have it the Blinky example successfully compiled and running on my Raspberry Pi Pico, and that's all Swift code, which I think is awesome. The problem has to do with that they're probably not going to even support this ever. It's just they dumped in some examples on their repo and that's it. I'm not seeing any responses come back from anyone for any of these things. And so I tried to get this running on Linux. And so I went through all this rigmarole to get this to happen. And I do have, so if you want to get this to run on Windows or Linux, if you're on Windows, I recommend Docker Desktop or Desktop Docker for desktop using WSL2 or just use WSL2. I have the Docker pull commands and then all the stuff that you would need to actually get at least the Pico W blinker example to work. There's a lot more that goes involved into the getting these little things running. And right now I'm running against some other issue because this is just a simple little blinker example. I'm working on trying to get a web server up and running in Swift to have all this happen. And then you can immediately say, hey, in their WWDC talk, they mentioned it's just Swift. There's a couple things like you can't use any type, you can't use reflection. No, there are more limitations than what they led on to. And this is what I was expecting and I wanted answers on. So I started looking into a little bit of it, and it becomes very clear that they do not support everything that they were talking about in this video. And maybe they have this in some way, like in their source code repository. I tried both the development branch and the 6.0 development branch. Neither of these fix any of the issues that I was running into. So let me go into a couple of things here. First, obviously I had to modify the CMake file. A lot of things that they were doing were Mac specific commands, and that obviously will not work on Linux or Windows. But the big but is they don't support variadic functions. So when you try to print and you print with formatting, let me see my Swift server thing here. You cannot print with formatted strings because it is a variadic function. At that point, you'll get some compiler errors and hey, we don't support variadic functions. Another issue, the most obvious one, is you cannot use a string. You have to use static string or some C string like structure. Let me see where that is at on my main. And so I'll have static string declared here, but then I need to interrupt with the C function to set up my Wi-Fi on the Pico W, and I have to do this rigmarole of unwrapping it, making sure it's safe, and then passing it into that via a pointer, because that's how the C function works. And other things like I have to wrap certain things of globals. And this is all Swift code. This is not C code or C++ code. This is, I'm assuming what Swift is doing is it's taking the headers and auto translating them into Swift like you would do in Rust, which is cool. I really like that. But then another issue I ran into is that they don't support certain macros. So one macro that I found that they do not support when they do this auto translation is they can't take a macro function to map to another macro function. So if you have an if-def on whether you're using threaded or non-threaded mode, there's a swap of the Pico W function that is to be called. You have to call the explicit version that you can be using there. You can't use the macro for that. So that was another thing I ran into. And then right now, the last thing I'm running into is atomic operations through threading. In the talk, they talk about, they support this type of stuff. And it's missing the atomic function in the POSIX memo line. And this is not code I'm calling explicitly. I'm assuming this is from either the Pico SDK or something in there. And like the thing is that it's specifically from this function here. So I'm not sure what this is doing inside of all this, but if I go ahead, I believe if I comment that out and then I go ahead and I go here and I take that out as well, it compiles just fine. But then obviously I don't have my TCP server running at all. So yeah, it compiled just fine. Maybe it's not from this explicitly. Maybe that, there's something in here that is a problem. I tried, if I just go ahead and uncomment all of this and then run it, let me see if that does anything as well. Yeah, okay. So it's one of these things in here. I would have to go through one by one, but then basically I need to find out where atomic is being called at, which then goes into my last point here. Again, they talked about they want to bring a developer experience beyond just the Mac. They were going to have better Visual Studio Code experience. And when you bring up Visual Studio Code, you're going to notice very quickly that everything's underlined red and there's no jumping to any functions or anything else like that. I do not have an answer as to how anyone can edit Swift other than on a Mac OS machine, because at that point, you get rid of a lot of stuff. Now, it's not to say that you can't get autocomplete for your own Swift code that you're writing here, but any interop that happens with the way that Swift bridges just doesn't exist for whatever reason. So they need to come up with a language server that will support embedded Swift and how it does its auto translations of C functions or C headers into Swift. Beyond that, there's not much else to say. I think it's very, very promising. My general issue is that what they showed off here was just like a very glossed over experience that really isn't reminiscent of that. And they have documentation specifically on how embedded Swift works. They don't really go into the nitty gritty even in that documentation, talk about all the explicit limitations. There are other things, for example, that you have to think about when working with embedded Swift over Swift. Allocation is a big issue. Swift is not a garbage collected language. It's not like C#. You can choose no allocation at all, which means you do not put memory on a heap. And you would normally go that route anyways, because normally when you deal with dynamic memory allocation, like a string, you have to isolate or take a bit of like your SRAM on your microcontroller, and say you have like 100, you take 50 kilobytes of the 100 and section off for dynamic memory allocation or the heap. That goes into a global namespace. The ESP32 is really good at that. In fact, they actually have a separate thing, a separate module on the this SPC to let you either use it as a file system or use it as like a slower RAM, but that could be used as like your dynamic memory allocation as well. And you have a lot of it access to. You have like megabytes worth of that. So I don't think it works very well in that context. You need these machines or these SBCs, microcontrollers, to have a lot of RAM available. And I'm saying like a quote unquote, like a lot of RAM, but it's a lot of RAM for a microcontroller to have the ability to use just Swift, which is not going to be the reality for a lot of these things. And you're going to be wanting to have that memory available to you for a lot of other stuff anyways. So I don't know. There's just some gotchas here that wasn't really clarified, and I think if anyone else has developed with embedded Swift before, this is a better solution than it was previously. It's just that they kind of glorified this in a thing, and there's a lot of like magic that's happening that I do not see or understand. I had to jump into some of the front end C++ code that the Swift compiler uses to try to figure out like how the hell is any of this crap working, and it's just not it's not very obvious, and again, it's not in their documents exactly how they talk about this. Anyways, that's my experience. Hopefully it will help you and save you a little bit of time if you're going to be jumping into this, because like I said, look at the Windows support ticket if you want to get this to run on Windows or Linux, or yeah, Windows or Linux. And then if you're on Windows, just probably use the Docker thing here that I have set.